In this lesson, we're going to talk about another type of product of vectors. We've already talked about what's called a scalar product, and of course, when you multiply a vector by a scalar c, you just multiply each of the components by that scalar. But the dot product is different. Thank you. And the dot product that's different because it's also called the inner product. It's different because in two-dimensional space, when we dot the vector u with the vector v, we get the result of u1 times v1 plus u2 times v2. That's the dot product of those vectors. Now here's what I would like you to notice. That u1 times v1 plus u2 times v2 is a scalar. It's a number. So dotting, the result of the dot product of vectors gives us a number. In three-dimensional space, it's just kind of what you would imagine. Well, if it's just like in two-dimensional space, except we also have u3 times v3 added. So u1 dot, or u dot v is u1 times v1 plus u2 times v2 plus u3 times v3. And again, it's a scalar, it's a number. Now you might be asking a good question, what is the dot product used for? Well, I can think of three things. Finding out how much of a force in one direction is actually acting in a different direction. You can use it to find out the angle between vectors. And you can use it to find out how much work is done when you're pushing something in one direction with a force that's not exactly in that same direction. So, what else can we look at here? I think we can do this. We can say, group exercise, let u be a unit vector along the x-axis. In other words, let it be the vector I, or let it in component form the vector 1, 0, and v be one of the following, a unit vector along the x-axis. So I dot I, see, we're determining what is u dot v. So this is I dot I, well that's 1 times 1 plus 0 times 0, so that would be the number 1. Remember, the result of a dot product is a number, a scalar. So a unit vector making an angle of 30 degrees with the x-axis, well, cosine of 30, you might recall, should recall, is square root of 3 over 2, and sine of 30 is 1/2, so it's square root of 3 over 2i plus 1/2 j, and when you dot that with I, you get square root of 3 over 2. A unit vector making up an angle of 60 degrees with the x-axis. Well, that would be cosine of 60i plus sine of 60j. You do know why I'm saying that, because cosine is the x component, and sine is the y component. And that's a unit vector, right? Because sine squared plus cosine squared equals 1. All right, back to our problem. So this would be 1/2. What about a unit vector making an angle of 90 degrees with the x-axis? In other words, I dot j, well, it's 1 times 0 plus 0 times 1. So if two vectors meet at a right angle, there's a word coming up later, we'll call it orthogonal, but if two vectors meet at a right angle, their dot product is 0. A unit vector making an angle of 120 degrees with the x-axis, well, that would be cosine of 120, which is negative 1/2, plus square root of 3 over 2j, negative 1/2 I plus square root of 3 over 2j. When we dot that with 1, 0, we get negative 1/2. So unit vectors could have, actually any vector in general, with another vector, when you dot them, they might have a negative result, and you might guess that means they meet at an angle greater than 90 degrees, meet at a non-acute angle. Of course, if they meet at 90 degrees, the dot product is going to be 0. So, hope that was useful information for you.